Okay, so we have what looks to be a geometric series, and let me just remind you that when we're dealing with a geometric series, we've got the sum k equals 1. If we want to use geometric series facts, we have to sort of take our series and put it into this standard form. So this is a times r to the power of k minus 1. This is equal to a over 1 minus r. A and R are both constants, but the a doesn't change as the terms of the sequence change. But this does, it's r to the power of k minus 1. R is called the common ratio, and a is called the multiplier or something. And so now, if we want to compute this sum, we have to write it in this form here. We have to write it as something a times an r to the power of k minus 1. And so now we sort of have to figure out how we can do this. So I'm going to start. So I'm just going to rewrite what I have. K equals 1 to infinity minus 4 to the power of k plus 1 over 5 to the power of k. Now, the first thing that I'm going to do is, even if the indexes aren't going to be quite right, in other words, I might not have a k minus 1 there, I might have a k minus 1 or k plus 1 or something like that. I want to try to combine this all into something to some power involving k. So I'm going to have this as k equals 1 to infinity. I've got 5 to the power of k. I've got k plus 1. So there's two things that I could do here. Here's what I'm going to do. I'm going to multiply this by 5. And if I do that, I've got k plus 1 over 5 to the power of k plus 1. OK, so now both of these are k plus 1. See, I multiplied by 5 here and then divided the numerator. The k went from k to k plus 1. So this is going to be k equals 1 to infinity 5, and it's going to be minus 4 over 5 to the power of k plus 1. OK, sorry, this looks less like a 4 than I want it to look. OK, same thing for this 5. OK, but this is k plus 1, but to use this formula, so I have a k plus 1 here. But to use this formula, I need to have a k minus 1. So I'm going to use this fact, k plus 1 is equal to k minus 1 plus 2. And so this is going to be the sum, k equals 1 to infinity. I'm going to have my 5. I'm going to have my minus 4 over 5 squared. I'm going to have my minus 4 over 5 to the power of k minus 1. And again, I'm just using the fact that k plus 1 is equal to 2 times k minus 1. OK, now what's going to happen, I can make this look a little bit nicer. So this is the sum, k equals 1 to infinity. OK, minus 4 squared, that's 16. I've got a 5 squared times a 5. So 5, I've got 2 5s in the denominator and 1 in the numerator. So this is just 5. And now I have minus 4 over 5 to the power of k minus 1. And now I can match this up with my formula here. This is my a, and this is my r. Notice that this formula is true if and only if the absolute value of r is less than 1. If the absolute value of r is greater than or equal to 1, the series diverges. The absolute value of r is equal to 4/5, so this converges. And this is equal to 16 over 5 divided by, it's 1 minus r, but r is negative, so this will be 1 plus 4/5. If I get a common denominator, in the numerator, I'm going to have 16 over 5. And the denominator, if I get a common denominator, 1 is 5 over 5. So this will be 9 over 5. And then the over 5s cancel. And this is 16 over 5. And that is the final answer to this problem. 16 over 5 is the sum of this geometric series here. The challenging part for this is going to be figuring out how you can manipulate the thing that we're adding to get it into this form here. There's other ways to do it. You could have, Up here, you could have taken away, a -4 and had -4 to the power of k over k, and then something like that. There's a number of ways that you can rearrange it. This just happened to be the way that I rearranged it.